Good evening, friends. Good evening, friends. A new topic which is known as Geometric Progression GP of Class 10 ICC board, and it is it all boards like ICC, CBSC, state boards, and all boards. In the description, I have written ICC board, but it is complaint with all board. Now, I will be going to explain what is a geometric progression, and before explaining what is geometric progression, I will be explaining you what is a sequence, and then I will be explaining you what is a geometric progression, what is the common ratio, what is a presiding term, okay, what is presiding term, and at last, what is the formula of the nth term or the last term? And then we will start to solve problems based on GP, that is geometric progression. Okay, let me start now. Let me first share my screen and start the chapter geometric progression, which will be presented in front of you in the laptop screen. Okay, so let me start now. Is the screen visible to you? So now I will be going to start the topic which is known as geometric progression. G E O M E T R I C, geometric progression. Is it clear to you? So first, in order to solve the problems which are based on geometric progression, first we have to know what is a sequence. Okay, so can you please help me? So can you please tell in the chat box what is a sequence? Anyone who like to try to answer me what is a sequence? Please. So what is a sequence? Sequence. So what is a sequence? A sequence is a arrangement of numbers which are written in a definite order. So what is a sequence? Sequence is a arrangement of numbers. Arrangement of numbers which are written in in a definite order. So what is a sequence? Can you give me some example of sequence? So now I will give you some example of sequence. So example of sequence is 2, 4, 6, 8, 10, and so on. So why these numbers are in sequence? Here I have written the example of sequences 2, 4, 6, 10, dot dot dot. So can you tell me why these numbers are in sequence? Because here we can see that here the numbers are written in definite orders. So we can say that to obtain 4 we have to add we have to add 2 into it. Now in order to obtain 6 we have to add 2 into it. In order to obtain 8 we have to add 2 into it, and in order to obtain 10 we have to add 2 into it. Now what will be the next number if we want this arrangement to if we want this number to be in sequence? Can you please write in the chat box what will be the next number if we want these numbers to be in sequence? Please someone write in the chat box. So here the next number will be 12. Why? Because in order to obtain 12 we have to add 2 into it. Okay, so here we can say that these numbers are in sequence. Now I will give you another example, which is 2, 6, 54, and so on. So are these numbers are in sequence? Definitely yes, because these numbers are arranged in some orders, in a definite order, and you can see that here the second term is 6. 6 is the second term, and in order to obtain 6 we have to multiply 3 with 2, then we will get 6. Now in order to obtain 18 we have to multiply 3 with 6, and in order to obtain 54 we have to multiply 3 with 12. Is it clear? and in order to multiply 54 we have to multiply 3 with 18. So we can definitely say that these numbers are in sequence. So I think now you have understood what is a sequence, and you have to know it by heart, that what is a sequence. If someone asks you what is a sequence, then you, I think now you can definitely tell them what is a sequence. Sequence is nothing but it is just the arrangement of numbers which are written in a definite order. Okay, so now come to the main definition of geometric. So what is a geometric progression? So what is a geometric progression? Geometri, geometric progression. So what is a geometric progression? Can someone help me? What is a geometric progression? Geometric progression is nothing but it is a sequence in which each of its term can be obtained by multiplying or dividing its preceding term by a fixed quantity. So geometric progression is nothing but it is a sequence, but but it is a sequence. Geometric progression is nothing but it is a sequence which can be obtained, which can be obtained by just multiplying and dividing its preceding term a fixed quantity. So what is a geometric progression? Geometric progression is nothing but it is a sequence which can be obtained by just multiplying or dividing, which can be obtained by just multiplying or dividing its precise by a fixed quantity. Is it okay? Now I think you know the definition of geometric progression. So what is a geometric progression? Geometric progression is a sequence which can be obtained by just multiplying and dividing its preceding term by a fixed quantity. And it is a very easy definition. Okay, now I will give you some example of geometric progression. I will give you very easy examples of geometric progression, and it will be very helpful to you in coming future. Okay, so now let me start to give you some examples related to geometric progression. So I will give you example as Examples. Example. That is 3, 6, 12, 24, 48, and so on. So, is this sequence is in geometric progression? Can you please help me to tell if this sequence is in geometric progression or not? Yes, this sequence is definitely in geometric progression, because here in order to obtain 6 from 3, we have to multiply it by 2. Now in order to obtain 12 from 6, we have to multiply it by 2. Now in order to obtain 24 from 12, we have to multiply it by 2, and in order to obtain 48, here also we have to multiply it by 2. Is it okay? So here we can find that in order to obtain the next term, we have to multiply the preceding term by 2 in each case. So we can say that this sequence is definitely this sequence is definitely a geometric progression, as this sequence is obtained by multiplying 2 with its preceding term. Is it okay? So now if someone asks you what is a geometric progression, you can definitely answer them what is a geometric progression, and I have given you a very easy example of geometric progression. So now let me give you another example of geometric progression. Okay. So here another example of geometric progression is 6, 2, 3, and so on. So is this sequence is in geometric progression? Definitely this sequence is in geometric progression, this sequence, because in order to obtain the next term, we have to multiply the preceding term with 1 by 3. Is it okay? In order to obtain, in order to obtain 2 from 6, 2 from 2 from 6, that is in order to obtain the next term, we have to multiply 6 by 1 by 3 is equal to 2. So in order to obtain 2, we have to multiply the preceding term with 1 by 3. Now in order to obtain 2 by 3, we have to multiply 2 with 1 by 3. So here we can see that the sequence which is obtained. So here we can say that the sequence is obtained by just multiplying the preceding term with 1 by 3. So we can say here that the given sequence is definitely a geometric progression. Is it okay? So now I will now tell you what is the common ratio. So here, what is the common ratio? Common ratio is nothing. Common ratio is nothing, but it fixed quantity. Okay, common ratio is nothing, but it is just the fixed quantity which we are using to obtain the next term from the preceding term. So in this question, so in this sequence, that is 3, 6, 12, 24, and 48, the common ratio is 2. Common ratio is 2. Is it clear to you? Because we are multiplying 2 with the preceding term to obtain the next term. So what is it? The common ratio? Common ratio is nothing but the fixed quantity which we are just multiplying and dividing to obtain the next term from preceding term. Okay? And the common ratio is denoted by small r. The common ratio is denoted by small r. Denoted by small r. Is it clear to you? So please give me a thumbs up if you have understand the concept clearly. What is a sequence and what is a geometric progression and what is common ratio. Up to this I have told you three concepts. That is what is a sequence, and then what is a geometric progression, and how we can tell a sequence in geometric progression or not. And I have also told you what is the common ratio. So please give me a thumbs up in the chat box. And then now I will go to the next concept. Okay. So now the next concept is, so now what, so now I will tell you about general terms which are used in geometric progression. Is it clear? So now I will say you about general terms which are used in geometric progression. Okay, general terms which are used in geometric progression. Okay, so now here let the first term of the geometric progression be denoted by A. So the first term FIRST, first term of the geometric progression is denoted by A. So if someone says you what is the first term of the geometric progression and by which letter it is denoted, you will say that it is denoted by small a. Okay. So first term of the geometric progression is always denoted by small a, and the common ratio is denoted by small r. Common ratio, common ratio is denoted by small r. Is it clear to you? So the first term is denoted by a, and the common ratio is denoted by r. The first term is denoted by a and common ratio is denoted by r. So now the last term of geometric progression is denoted by L. Now the last term, L A is the last term of GP, that is geometric progression, is denoted by is denoted by small l. Is it clear to you? So please give me a thumbs up in the chat box if it is clear to you. So the first term of this geometric progression is denoted by A, the common ratio is denoted by R, and the last term of the geometric progression is denoted by L. So please give me a thumbs up if these three things are very much clear to you. Okay. Now I will write the formula of the last term. Okay. So now I will write the formula of the last term for you. Okay. So last term, LAST, last term of GP, that is L, is equal to A r to the power n minus 1. Is it clear? So here A is the first term. Formula you can see that A is the first term, R is the common ratio, and then what will be the N? N is the nth term. Is it clear? That is the general term. So then what is N? N is the nth term. That is, it is the general term. It is the general term. That means in the question it is given that the seventh term of GP. Then we will put the value of N as 7. Okay. So here nth term is equal to nth term is equal to a to the power r n minus 1. So now if I put n as 8, that is, if in the question it is given the 8th term, then I will write as 8th term is equal to a to the power r minus 8 minus 1 is equal to a to the power a r to the power 7. And if n is given as 10, then what I will write? I will write is equal to a r to the power 10 minus 1 is equal to a r to the power 9. So have you understood now what is n? N is the nth term, and the formula for nth term is a r to the power n minus 1. So I think it is very much clear to you. what is the nth term or what is the general term and what is the last term. So now we will start to solve some problems related to okay. So now I will be starting with the exercises which are related to geometric progression. Is it clear to you? So here the first question is given as exercise 11a. What is the first question given? Here the first question is given as if the first term of the GP is 8 and its common ratio is minus 2, the third term of this GP is. So here the first term of the GP is given as 8. So here the question is if the first term of a geometric progression is 8 and common and its common ratio, not difference. Common ratio is minus 2. The third term of this GP is the third term of the GP is. Okay. So what is the question given? Here the question is given as the first term of GP is 8. The first term of GP is 8 and the common ratio is minus 2. Is it clear? So now here we will take what is the first term? It is 8. So A is equal to 8 and R is equal to minus 2. Here we were denoting the first term as A, which is 8, and the common ratio is minus 2, so R is minus 2. And here we have to find N is equal to 3. We have to find here the third term, that is the value of N will be 3. So now what is the formula of GP? The formula of GP is nth term is equal to a to the power a r to the power n minus 1. So which term? So third 3th term is equal to what we have to put the value of a as 8. Here the value of a is 8 8 into minus 2 to the power 3 minus 1 is equal to 8 into minus 2 to the power 2 equal to 8 into what is the square of minus 2? The square of minus 2 is 4. Then it will be 32. So is it clear to you? So what is the third term of this GP? The third term of this GP is 32. Is it okay? So now I will be moving to the next question. Here the next question is given as. So what is the next question given? The next question is given as if you have any problem, then you can definitely ask me in the chat box. I will positively help your doubt. Okay, so you just put a comment in the chat box. I will definitely help you to solve your doubt. And if you like this session, then please like and subscribe this channel for your future reference. So now the question is the fourth term, the fourth term of a GP is 16 and the seventh term is 128. Seventh term is 128. Then what is the common ratio? Then what is the common ratio? So now can you please help me to solve this question? So here the question is given as the fourth term of a GP is 16 and the seventh term is 128. Then what is the common ratio? So what is the fourth term? Fourth term is equal to a into r to the power 4 minus 1, that is a into r to the power 3. Is it clear to you? Because the formula of nth term is a r to the power n minus 1. So by just putting 4 in place of n, we get a into r cube, and which is equal to 18. So epsilon it is equal to 16, and it is given in the question. The fourth term of the GP is 16. Now what is the seventh term? Seventh term is equal to a into r to the power 6, and which is equal to epsilon a into r to the power 6 is equal to 128. Is it clear to you, or I need to explain how I have written it? It is very easy. If you just follow my live sessions, then it will be very much easy for you to crack the questions of geometric progression. And I assure you, if you just follow my live sessions, it will be very much easy for you to crack the problems of geometric progression. Is it okay? So now here we have to find the common ratio, means we have to find the value of r. So we have to find the value of r from this question. So we can write a into r to the power 6 divided by a into r to the power 3 is equal to 128 by 16. So now a cancel out, and if we divide 128 by 16, we will get 16, how much? 16 8 ja. Okay. 16 8 ja 128. So we can write r to the power is equal to 8 by 1. Now r to the power 3 by r to the power 6, if we cut, then we will get r cube. So therefore epsilon r cube is equal to 8. And epsilon r cube is equal to 2 cube. Therefore r is equal to 2. Is it clear? Since we know that if the powers are equal, then the bases are also equal. Therefore r is equal to 2. Therefore here the common ratio is, here the common ratio is 2. Is it clear to you? So what is the common ratio? The common ratio is 2. So now I will be moving to the next question. And the next question is given as number C. 2x plus 2 and 3x plus 3 are two consecutive consecutive terms of a geometric progression. Okay, then the common ratio of GP is, then the common ratio common ratio of GP is. So here what is the question given? Here the question is given as 2x plus 2 and 3x plus 3 are two consecutive terms of a GP. Then the common ratio of GP is. Here there is a hook in this question. Here the question, here in this question it is defined as two consecutive terms. This is the main hook of this question. Okay. Two consecutive terms. So here the nth term is 2x plus 2 and n plus 1 th term is equal to 3x plus 3. Is it clear to you? So as they are two consecutive terms, so here nth term is 2x plus 2 and n plus 1th term is 3x plus 3. So what is the meaning of consecutive terms? Means if this is the first term, the nth if this is the first term, then this one is the second term. If it maintains the consecutiveness, then we can say that if nth term is the first term, then n plus 1th term is the second term. So we can write this one. So now we can write here, and we know the formula of nth term of a GP, and the formula of nth term is nth term is equal to a to the power r n minus 1. Okay, now n plus 1 eighth term is equal to a to the power r n plus 1 minus 1. Now I think it is very much clear to you why I have written the power of r as n, because here we have to find the value of n plus 1. Okay, here we have to find the value of n plus 1. So now we will write, and what is the value of nth term? The value of nth term is, we will write as a to the power r n minus 1 is equal to, and for this one we will write a to the power r n plus 1 minus 1 is equal to 3x plus 3. So from here we will write a to the power a, not a to the power, a r to the power n plus 1 minus 1 is equal to 3x plus 3 epsilon a r to the power n is equal to 3x plus 3. So now can you tell me which one is greater, a r to the power n minus 1 or a r to the power n? Which one is greater between these two, this one and this one? Which one is greater? Please tell in the chat box. Please let me know in the chat box which one is greater, a r to the power n minus 1 or a r to the power n. If someone can tell me, please write in the chat box. I will definitely see which one is greater. So here we will see. So here a r to the power n is greater than a r to the power n minus 1. Okay. So therefore we will take the ratio of these two equations. Okay. To the power n divided by a r to the is equal to 3x plus 3 divided by 2 divided by 2x plus 2. Now we will solve this question. No, now we will solve this equation to find the value of r. A cut. So r to the power n by minus 1 is equal to 3x plus 1 by 2x plus 1. So we will cancel these two and we will write r to the power n by 1 by r to the power n divided by r. So rn cancel, equal to 3 by 2. So epsilon r by 1 is equal to 3 by 2. So here we can see that the common ratio is 3 by 2. Is it clear to you? What is the common ratio? Here the common ratio is 3 by 2. Now let me check the answer of this question. So let me check the answer of this question, and the answer of this question is 3 by 2. Therefore the common ratio is 3 by 2. Answer. Okay. Now I will move to the next question. If you have any problem or any doubt, then you can definitely write your doubt in the chat box. I will positively help you to solve your doubt. Is it clear? So now I will jump to the next question. Here the question is given as the third term of a GP is 3. The product of its first 5 is. So the question is given as third term of a GP is 3. Okay, of its first 5 term is the product of the first 5 term is. So here the question is the third term of a GP is 3. The product of the first 5 term is. So how we can solve this problem? We all know that if there is a will, then there is a way. So how we can solve this problem? Can you give me some idea how to solve this problem? The question is in front of you. Any idea to solve this problem? So here we can see that in this question it is given the third term of a GP is 3. So third 3th term is equal to a into r to the power 3 minus 1, and it will be equal to a into r to the r square. Is it clear to you? So a, so therefore a r square is equal to, because the third term of the GP is 3. Now, what is the first term? The first term here, the first term will be A, the second term will be AR, the third term will be AR square, the fourth term will be AR to the power 3, the fifth term will be AR to the power 4. Is it clear to you? So now, when we will multiply all these terms, we will get. Now we have to multiply all these terms. Here the first term is A, second term is AR, third term is AR square, fourth term is AR cube, and fifth term is AR to the power 4. Okay. So now we will multiply all these terms, and the resultant will be obtained as product of first five terms is A into AR into AR square into AR cube into AR to the power 4 is equal to A to the power 5 and R to the power 2 plus 1 3 plus 3 is equal to 6 10. Okay. So now we can write AR square bracket 5. Why we can write this one? Because, if we write this multiplication with respect to the third term, we can write this one. Okay. So now we know the value of AR square, and the value of AR square is 3. So 3 to the power 5. So the product of first 5 terms will be 3 to the power 5. Okay, and this will be the answer of this question. Is it clear to you? So I think now you will be able to solve any questions like this if only one term of the GP is given and we have to find the product of any terms. Okay, so this is the method to solve this question. Now I will move to the next question. And the next question is, the eighth term of the GP is 192. The eighth term of the GP is 192. So now the eighth term of the GP is 192 and its common ratio is 2. Its common ratio is 2. Then the first term of the GP is, then the first term of the GP is. So here the question is given as the eighth term is 192 and its common ratio is 2. Then the first term of the GP is. Okay. So how we can find the eighth term? In order to find the eighth term of the GP, we will write eighth term is equal to a into r to the power 8 minus 1 is equal to a into r to the power 7, and this is equal to a into r to the power 7 is equal to 192. Okay, because here it is given that the 8th term of the GP is 92. So here it is reflecting a into r to the power 7 is equal to 192. So now here it is given as the value of r is given, and the value of r here is 2. As it is given, the common ratio is 2, therefore the value of r is 2. So now we will put the value of r in this given equation and find the value of a from it. So it is a very easy question. We will just put the value of r in this given equation, a into r to the power 7, and we will find the value of a. Is it clear? So now epsilon a into 2 to the power 7 is equal to 192. Okay, therefore a is equal to 192 divided by 2 into 2 into 2 into 2 into 2. We will write 2, 1, 2, 3, 4, 5, 6, 7, and find the value of a. So now going to solve this. 2, that is 96. 2, that is 40. Cut 24. 2 cut 2 cut 6. 2 cut 3. That is the value of a is 3 by 2. Therefore, the first term is 3 by 2. Therefore, the first term is 3 by 2. Is it clear? So here we have to find the first term, and the first term is 3 by 2. So thank you so much for giving me a patient hearing. If you like my sessions, then please like and subscribe this channel for your future reference, and it will be, I am telling you, it will be very much helpful to you in your coming examinations or any competitive or your school examinations, and it will be very helpful to you in your near future. So I am signing off from this now. So I am signing off from this session. So thank you so much for giving me a patient hearing. Okay. So thank you so much. Please like and subscribe my channel, and these questions will be very much helpful to you in your coming future, and I will be coming with more geometric progression questions in the near future. So thank you so much. Okay.